of interest for a lot of engineers, and with the climate change and all that is happening, this will become even more important. And that's another area that we at AIT are looking at. And I'm sure we will get a chance to talk about that later in the day. But right now, I want to talk about some of the things about the advancements in technology and also in structural engineering that must come together, or that are coming together to make the infrastructure future proof, because that's the focus of the talk today. So let me start this discussion by, first of all, re-emphasizing what has already been mentioned by Ashraf very clearly. And he said that we can't have economical development without the built infrastructure. So built physical infrastructure is the backbone of the economy and the society. Everything that we see here is part of the built environment. In fact, when we look at the development of the civilizations, one of the things we look at is how well the infrastructures were developed, which includes building and roadways and transportation and other network and waterways and things like that. So the built environment is essential for any economy to develop and any society to progress. So that is quite clear that the built infrastructure, physical infrastructure, is an integral or important part of our society. So having said that, or having established that, then we see that the structural engineers are actually at the backbone of the built environment. So we have also seen from Ashraf's talk that how structural engineers contribute to the design of buildings, bridges, tunnels. In fact, anything that is ever built physically, structural engineers have to be involved in some way or the other. It could be, or every other discipline, every other development, every other infrastructure, that even the telecommunication infrastructure requires structural engineers to design the physical components of those infrastructure. So even if the data centers are being built to store the data centers have to be designed by structural engineers. So there's nothing that can be built unless the structural engineers design it. So structural engineering, civil engineering is the backbone of the physical infrastructure development, which is the backbone of the economic development and the society. So we have a really crucial role to play in this whole development. Now the question is, how do we do future proofing of what we do? So future proofing, if you look at this definition, is actually the process of anticipating the future and then developing methods of minimizing the effects of shocks and stresses of the future events. In fact, that's what we do. Structural engineers always are thinking ahead of what will happen to a building, in the next 100 years or 50 years of its life, what loads will come onto it, what can go wrong, and try to predict it and then design against it or prevent it from happening. And that's what we do on a daily basis. But we don't really think of our work as future proofing, because now the things are changing at a faster rate than in the past. The climate change effects and many other things are coming up. So because of that, we have to probably explicitly think about future proofing our design, not just doing the design on a regular basis. So the role of structural engineers is actually, as I mentioned, is very important in the infrastructure development, and infrastructure future safety or future proofing is also our responsibility. So we have to help make the physical infrastructure future proof through our work. And that's what we are just discussing in this whole event. And what Ron mentioned is another important aspect of how we can make better, taller buildings, which is safer, and we can design them for greater hazard levels that we anticipate in the future. So what makes a built environment future-proof? Obviously, it remains to be serviceable for a long time, for its entire life. In fact, we normally say the building life is 50 years of structure, but the main infrastructure needs to last much longer. It needs to be always safe. And this is a topic that we will talk a lot about this day. It needs to be resilient. And as you know, resiliency goes beyond safety, and it's a concept beyond just being safe. It talks about a lot of other things which go after being safe. So it has to be resilient, and it's resilient also it lends resilience to the economy, to the society, and so on. It has to be flexible. It should be able to change with the future needs. It should be adaptable, adapt to the changing guidelines, changing rules, and changing new developments. So it has to be adaptable from that point of view. It has to be sustainable. Environmental sustainability and all kinds of sustainability has to be built into the design, and it has to be dismantleable. In the end of the life, it has to be, we should be able to take it down safely and with minimum loss of the resources. So all of this, if we consider that in the design explicitly or implicitly, we are making the built environment future-proof. Now, for the structural engineers to be able to do that, we have to continue developments in structural engineering, like the one we just saw, lab testing, 15 years, 20 years. It took a lot of time to develop a new system that will continue, and that similar things goes into methods, in processes. Then, so that is the development in the structural engineering field itself. Then is the other developments going on which are outside structural engineering or civil engineering. We have to make sure that we bring them in and we integrate those emerging technologies with our structural design process and take the best advantage from everything that is happening around us. We cannot just only focus on our field. We have to see what are the things that are happening, what other people are doing, and how we can bring them in. And obviously, we need to develop tools and software that use these technologies to the best and put them in practice and make them practically applicable. So we need a basic development in our own field. We need to make sure that the other technologies are brought in, and then we need to put this whole thing into software and tools that we can use and effectively and apply them. So that's typically what structural engineers are doing and are to be doing. Let me just briefly give an overview of where the structural design approach is going. And a long time ago, people used to start by intuitive design. There were no design code, there were no computers, there were no calculations. People just had a good intuitive sort of sense, and those master builders will design many things. And then after that, the building codes came in and they codified many things. They gave us told us what to do, what not to do, how to do. And so there's a whole discussion on code-based design. And then from there, we moved to performance-based design, as Don mentioned in his presentation, and then we will talk more about this later. So performance-based design now comes in, which gives us a more explicit way of developing new systems which go beyond the code. And after that case comes risk-based design, which means that we talk about the risk explicitly, which is more than performance. And this also looks at what happens if the performance is not met. And from that, we move to resilience-based design, how these decisions will make the structure resilient. Resilience goes beyond structural safety, it goes beyond structural damage, it goes to human loss, it goes to cost of infrastructure or building not being used, and so on. So it's resilience design, and then that will leads to an explicit future-proof design where we have requirements for each of the future aspect to be considered. So that's how the structural design process is developing or is ongoing, as we can see. And then there are emerging technologies which are happening all around us, and we use them all the time in our work. Artificial intelligence, 5G and Internet of Things, serverless computing, biometrics, augmented virtual reality, blockchain, robotics, natural language processing, quantum computing, and you name it. There's so many things happening. And I will just be showing a few of them very quickly and see how they can help in our work and help in making the structure and infrastructure future-proof. So the role of software in all of this is very, very significant, because all of this can't be done by hand anymore, as some of us who are old enough to remember the use of hand calculations and slide rules and things like that. Those days probably aren't coming back. So we have to rely on computers and computing and software and tools. So that means anything that we do ultimately will have to be part of some software. So we need to have software that support the design process. We have to help integrate emerging technologies into the process. So I'm talking about the software development process itself. People who develop software, they need to do this. They have to help simulate lab-based testing and future scenarios. In fact, a lot of the time, if you look at the research, it's a two-part research. The one part is lab testing and one part is simulation. And we try to bring that together so that the simulation is reliable and it can be based on lab testing, just like the development we just saw, where lab testing, mock-up models, and everything that led to software to be used for the final design. The final tall building was not tested in the lab, was not a mock-up. It was designed based on the simulation that was possible because of the software that was developed. And then software also helps us to visualize the enormous input and output in a multi-dimensional environment. So that's the role of the software, and we all know how important that has become. Now, there is the purpose of technology should be very clear. This should be basically to make the process easier and more efficient. That should be one aspect of technology. Technology cannot be used for the sake of technology. It needs to help something. So it has to help the process to run faster or more efficient. And also give us the ability to create a better system. That means not only to do what we do better, but also to do something new that we couldn't do before. So that's the right purpose or right use of technology in the end. It's a tool. So we should always see how the technology can be most effectively used to make what we do better and also to create something which is better. I'm going to run through very, very quickly a few slides just to show you, typically what are the key technologies. I'm sure everybody attending this event knows about them. Artificial intelligence and the machine learning is, we hear all about always they're taking over the world, and with the robotics, and we have so many, good and bad things coming out of it. People are talking about the statics. We're talking about all the other things related to that. But the reality is that both AI, machine learning, and robotics are going to change things significantly for the things to come. The artificial intelligence, machine learning, deep learning, they're all phases of development starting in the early 50s, and now it's going on, and this will just continue as you can see. So we have got to make sure that we bring this into our workflow, our process. Then big data, again, it is said that we create and use more data. We create more data in one day than it was created in the entire human history before the last century. So there's a large amount of data being created everywhere. And then a lot of tools to dig, search, utilize this data analytics, data mining, so many terms are there. And we talk about big data. So everything, as you know, is now, because it's digitized, it's data and it's available somewhere and it's going to be connected. So we have got to learn to utilize the data that has been created. It's experience. It's a cumulative experience of billions of people, of billions of hours of and man months, person months. So we need to build upon that. So if we can make use of the big data, that will be really great. Sensing technologies, we have now sensors everywhere. Even a small, a cell phone has like 20 different sensors. A watch has, so many sensors. Sensors are everywhere. And those, we have got to make sure that how we can utilize these sensing technologies and sensors to the best advantage. You have temperature, humidity, air, motion, acceleration, light, magnetic field, sound, GPS. All kinds of sensors are available very cheaply everywhere. And they are installed in so many places. The challenge is to get the data from them and make sense out of them and see what information, what signal that they're sending is something that we can utilize. Quantum computing, as you know, is going to change the way that the entire computing is done, from 0-1 base to something in between. So that quantum computing is a completely different way. It can solve problems that have never been solvable, theoretically not solvable by computers, by classical computers. So that's what we are looking at, and we should be ready to sort of embrace the quantum computing when it becomes more accessible. Blockchain, we have heard a lot about that, and this is especially something that people think about. It's a reliability, it's a trust thing. So for the future proofing, I think the reliability of the things, and to be able to trust something and to be able to document something which is completely verifiable is something that the blockchains can really help us to do. How can we bring what blockchain into our process, into the development of the infrastructure? Already many applications are there in many fields, and even in our field, people are looking at how we can use blockchain to tag things and then monitor or track those tags or track those events. Drones, as you know, everywhere the drones are there. They're there for delivery, they're for imaging. So, and they are now becoming more easier to use, cheaper to use, and so on. So we should see how the drones can help us. And I'm going to show a few of the examples. Construction automation is another area where the robotics are now getting more into the construction. Bricklaying used to be, as you know, a typical way that humans would be very good or have been very good at since the beginning of the civilization. And now the robots can do that, if not better, just as well, or maybe faster. So this robotics and automation in construction is something, again, that we should embrace and make it part of our process. 3D printing is another part of the construction automation. Recently, many 3D buildings have been completed, and this is not only going to impact the way the buildings are constructed, but also the way they are designed, the way the detailing is done, the way the process is completed. And so this whole process of automation, 3D printing, and all of that will also impact how the future infrastructure is built. IoT is like a culmination of many of these things because it gives us the ability to connect everything together. So the Internet of Things is a way to basically connect all the disparate things that I showed earlier and make sense out of that. So this is already being used extensively, and sometimes we don't even know it, that IoT is being used, but definitely as a field itself, IoT has a great potential because it helps us to integrate many things together and bring them into one platform or one framework. Smartphone, as you all know, is actually a way to access maybe majority of these applications. And someone said that if your future development does not involve a smartphone, your development has no future. This is an exaggeration, but it's true. A lot of the things that happen these days, somehow or the other, the cell phone is involved. Look at the pandemic management and everything. Tracking is done by the cell phones, and then we have QR codes. We have this. You can just basically track anything because everybody has this device, which has so many sensors, which is connected to the internet. So the IoT is there, the sensors are there, the data mining is there, the AI is there, and imaging is there, and visualization is there. So everything that we need is available to us. So if our design process, our work also includes this device as part of the work, it can just make things better. So now we are looking at a convergence. That means things are converging. Structural engineering and technologies and IoT and other things, they are coming together, not only in our field, in every field. Medicine, for example, is way ahead of everybody else. In fact, most of the new technologies first get into medical applications and medicine. So robotics are over there, the 3D printing was over there, imaging was over there. So similarly, structural engineering, we are looking at the health of the infrastructure. So we could also learn from what the medical profession is doing by rapidly, absorbing the new technologies. Smart cities is one example of that, when things come together in a larger scale, when everything converges, and then you can bring this whole thing together, open data, culture, standards, infrastructure, smart buildings, IoT, retail, energy, mobility, citizens, everything comes together, and then smart cities are created out of that. And then there's so many aspects of that. And obviously engineering, structural engineering, civil engineering is a major part of developing these new ways of building our cities, which are also designed to be future-proof. So let's come back to see how these emerging technologies and structural engineering actually can match with each other. So I'm going to just give you some very brief introduction to this one. First of all, we should recognize that there's a paradigm shift. Earlier, when the computers came in or the technologies came in, we used the computers or technologies to automate the existing process. So we just, whatever we were doing, we tried to make it work better. But now, at this point, the processes are developed that are based on technologies. That means we have to think differently. We have to think, what can I develop which will use these technologies rather than use a technology to make something that I'm doing better. As I mentioned earlier, the purpose of technology is both. So we have to see how the technologies that are coming up, we can use them to make things better, not just make what we are doing faster or better. The life cycle approach, of course, is always the right way to start. We should see where we can apply these technologies from the conception, planning, design, modeling, analysis, design, detailing, construction, operation, and end of life. So if we look at the technologies in each one of them, then we will be able to see what technology is most suitable for what aspect. And I just try to make some rough metrics of how these things will mesh together. So first of all, let's look at the development in structural engineering and its relationship to future proofing. So I mentioned earlier that the structural engineering design process is developing: intuitive, code-based, performance-based, risk-based, resilience-based, future-proof. How does each of that relate to various aspects of future proofing is what is shown here. And we don't have time to go into all of that, but you can just see the darker color means that there is more relevance. Lighter color means there is less relevance or there's less application. And these are just based on, very intuitive kind of a linkage. So we can just see that the performance-based design is heading towards higher application, resilience-based design even more. And if we do future-proof design, then it will be more related to future-proofing. Similarly, we can look at the technology application and structural design process. And again, different technologies, AI, data analytics, big data, virtual reality, mixed reality, augmented reality, IoT, blockchain, robotics, drones, and how they relate to various aspects of our design work. And you can see here that AI, data analytics, VR, and IoT, they all have a lot of relevance to various parts of the work, various aspects of the work that we do. So especially you can see in planning, AI could be very useful. Data analytics would be very useful for monitoring. IoT could be really very useful. So this is just a quick way of what is the relevance of these technologies to what we do and which one are most relevant to that. And then this can be used as a rough indicator of where the development is focused and can be focused. Similarly, we look at technology applications to future-proofing, how each technology will help for the future-proofing. And again, you can see IoT and as well as data analytics may help a lot. AI in some areas, blockchain may also help in some areas. So again, this is like I mentioned, this is a rough metrics. Other people may be looking at it in a different way, but this is what I look at this point and how the technologies have a relevance to the future-proofing of the built infrastructure. Something about AIT and the same metrics. I would like to show what AIT is doing in this respect. So AIT, design, development, and future-proofing. So the dark areas are where our research is focused on. So you can see performance-based design is one area. We're doing a lot of work there. We're also doing work on resilience-based design and also in risk-based design and others. So that's some of the work the structural engineering group especially is doing at this point. AIT technology and design process, and you can see here we are working on the application of the virtual reality, of AI, of drones, and IoT in various areas. So this is some of that will be talked about today in our afternoon sessions. Technology and future proofing, and again, so the work that we are doing at, as you can see, AI is some, IoT is some, and then some area in blockchain and some data analytics. So this is some of the areas where there's research ongoing and planned for the future. And this is an area where our students and our researchers are looking at how we can bring in the technology to make the structures, infrastructure future-proof. So I'll just present a few of the theses from our students very briefly, just the topics so you can see, like for example, using data analytics approach to estimate the efficiency of structural design of tall buildings, and we can develop the rating system. So there's a new framework developed recently by one of the students here. Then calibration of structural models using measured building response. So that's related to how we can calibrate building response and models that we make with the actual buildings that are instrumented. So we can bring that back and we can instrument and make our models much more reliable. Image-based inspection and monitoring of tall buildings. For example, you can use drones and other imaging techniques to detect cracks and to monitor them. So that is, another area that the students have worked. Enhancing seismic resilience of non-structural measures for tall buildings in Manila, for the Philippines, for example. So some researchers look at how we can take the buildings and make them more resilient by looking at the non-structural damage in a particular country. And this is the framework that they use. This is artificial neural network-based approach for the seismic fragility analysis of highway overpass bridges. How can we use the artificial neural networks for example, generating the fragility and the reliability of the bridges, and so on. There's a lot of talk, in fact, on fitness and personal health at this point. Many of us wear these devices or watches or smart watches or fitness devices that monitor everything that we do all the time. For example, they monitor the heartbeat and heart rate and so many things. And with using a few sensors, they can tell us what's happening with our body, and it can help to make our body, plan our health and make it better for the future. So same thing can be done for buildings as well, as you know. So network structural health assessment and post-earthquake response of tall building is another area that we are working on, where you can use the sensors placed in the buildings and bring them together and monitor them all the time to see how they are performing and what is the future expected performance. So this is just the framework for that smart system for post-earthquake assessment. And this is something that we are working on in Philippines to implement on some of the buildings. Drones, I mentioned again, so this is another interesting project where the drones are used to actually take images of an old fort, which is about, I think, 700-year-old, create a 3D model, convert that model into a finite element model, do the assessment, do the seismic hazard analysis. So because the physical measurement of this fort is difficult, so you use drone imaging as well as you use the internal the LiDAR imaging to create the 3D models, and from that you can go back to creating finite element models. So this is now possible by using technologies of this kind. You can also use multiple technologies. In this project, we use 3D printing, we used wind tunnel testing, we used performance-based wind analysis, we used simulation, we used many things. We use drones to basically look at the design and construction and other aspects of a dome. So this is another area, example of where the various technologies can be used. Smart monitoring of construction project using drones again. So you can use drones to monitor the construction progress, and then you can compare it with the BIM models to see how much work has been done. So this is a sample, on one of the project, you take the drone images, you take the BIM model, then you combine them to see how much progress has been done, because both of them are on the same three-dimensional space. So things like this can be done for monitoring of construction as well as for accuracy and so on and so on. That brings me to the development of the building information modeling and bridge information modeling, which takes the design to multi-dimension, not only consider length, width, and dimension, also consider time, construction time, and what happens over time, plus the cost, plus the sustainability, plus the management after construction. So this several dimensions of BIM are possible because all of the data is integrated at the same time. So design can be done, and we can take it to different levels. And it can lead to integrated digital delivery systems beyond just analysis. That means we integrate all of the thing from the beginning to the end. Like I mentioned, the whole life cycle can be integrated into this digital delivery system. And Singapore is doing a lot of work on that. We're also helping on parts of that, working with the Singapore authorities. Software, as I mentioned, software are now also, a lot of software being developed. I just mentioned a few from CSI. because we are a part of the team developing that. And CSI is also, as we heard, has been working with, it has been supporting many of the events, and AIT and CSI have collaborated for over 20 years. So I just mentioned a few software that they are developing, and all of that is directed towards many technologies that I already mentioned. Cloud-based computing, for example, or having this cloud-based access to models and to be able to do things remotely is another area that will be useful, as I mentioned, having mobile devices connected to the models. So having said all of that, and we can see now that the technologies, robotics and AI and so many things are absolutely encroaching upon many things that we do, whether we like it or not. So the best thing is to embrace them in the right way. And as I've shown you, there are so many opportunities that we can use technology, and we can use them for good. Of course, technology can always be used for negative aspects also, but I'm sure as engineers, we always think about the positive aspects. As Ashraf said in the beginning, we want to make people's life better. So for that way, we have to embrace energy in the technologies in our field. But some people might say, will the technology take my job? Will I lose my job if everything is done by AI and robotics and computers? So this is just a light note ending my talk. And there's a website called Will AI take my job away, or will robotics take my job away? And if you go to that website and you enter, if your job is accountant or auditor as your job, then it will say that, yeah, 95% chances that your job will be automated by AI and computers in the future. And you say you're a computer programmer, it says 48% chances that your automated computing and automated software development will take over your job. And that's really happening. The software engineers are so good that they're writing software that writes software and putting themselves out of job. But if you enter civil engineering, there's only a 2% chance at this time that your job will be completely taken over by the computers and robots. How true that is, I'm not so sure. But this is, just an indication that at this point we are still safe. But we have to make sure that we embrace all the technologies, keep developing, keep innovating, and make sure that our jobs and our relevance remains so high in the future as well. So with that, I would like to thank everyone